Sitting here with Peter Malliaras. It's probably been 4 or 5 years since we last talked. You might have actually been my first Tendon podcast.
There you go.
So in the last 4 or 5 years, what's been going on with you?
Yeah, look, I'm still working at the university. I work at Monash as a full-time professor for, well, actually, I was 4 days a week. Now I've gone full-time, but I still see patients. So there's a couple days a week. It's a pretty good little setup now because we've got a really good clinic that we're affiliated with, and it's called Orthosport Victoria. And there's lots of really good and smart people there, biomechanists and other physical therapists, so and strength and conditioning people. So what we now do is we do a lot of research out of that center. So we've got 3 PhD students that are doing projects out of that center, which really works very well. So I'm there 2 days a week, and I also then fit in some patients during that time. And then so then I'm at Monash doing the research the other days. So that's pretty much it over the last few years. Just a bunch of continuing on with the tendon research, pulling me in all different directions.
Hmm. What's the most recent paper you were involved with?
Um, I think it would be, there's been a bunch this year. I think the most recent would probably be the Shockwave trial that one of my PhD students published, and that was out probably end of last year, but it is still going through the sort of social media mill. There was
Hmm.
a bit of interest because basically we showed Shockwave doesn't work, and that was not good news for a lot of Shockwave people. So we and that and it's a timely trial because there's now pretty good evidence in the Achilles insertion that it doesn't work when you add it to exercise. So when you add exercise and Shockwave together, the Shockwave adds nothing at all over even the short term
Hmm.
and the long term. Well, long term, we looked over 12 weeks pretty much. So that's probably one of the newer ones, but there's always a bunch of stuff coming out. A lot of them, like a little PhD studies that are not so interesting, but are contributing to our narrative and our research journey. They're still very important, but then now and then you get the really good ones that you're really invested in,
Hmm.
like that one. So that was a good one for me because I was a Shockwave user, and since we found the results, which was quite a while ago now, it's probably a year ago that we've known what the findings were. I've stopped completely using Shockwave in that time. Um, so that was the nail in the coffin,
Um,
pretty much for me.
what kind of was the proposed mechanism for Shockwave? Was it am I wrong? Was it created for kidney stones to like break up calcifications or something? And is that what the mechanism is for tendons too? Is if you have calcifications, Shockwave should break it up and decrease pain, improve performance, or what is it?
Yes, that was the initial thing, breaking up calcium, and that's when it first started getting used. And it was first used mainly in insertional and calcific tendinopathy, and where there was calcium deposits. But then there was drift, and that people started using it for all types of tendinopathies. And then it started to be used for pain, and the mechanism then became there's a change in the biochemical environment where stimulating cells, they're going to be releasing biochemicals, so you might get a mechanotransduction type effect. So that was where it sort of went afterwards. But if you really look at the plausibility of those arguments, they're not very strong, because we know that the tendon cells are very smart. They're not gonna, if you signal with shockwave and you give it lots of repeated compressions, in effect with a shockwave, it's not going to like that. So whatever mechanotransduction you're going to get anyway, it's probably not good. So we were using it on the proviso that, or on the sort of premise hypothesis that it was maybe giving some effects in terms of pain modulation. And that's, a broad term, but maybe there was something happening there. And that's how I was arguing the use of shockwave, and I was using it in clinic. But yeah, now that we've found what we've found, I have stopped using shockwave.
Hmm. What when you're using it in clinic, I've only had a few people that have reported back to like I don't know if some liked it, but some of them would be like it actually was more painful acutely, and
Mm,
it was like you
mm.
had to do a number of sessions before the proposed mechanism would take hold. What were
Yeah.
you seeing in clinic with Shockwave, or was it like you were just doing too many things to know?
Yeah, look, you would be able to get an effect short term for some people. So some people, you do the shockwave, you might measure something like, say, an Achilles patient, their hopping pain, and then you do the shockwave, and you measure it again, it goes down, and it goes down a lot. And they thought, wow, this is incredible. And I was also surprised. But you run with it. With some people, it work. It seemed to work. Um, but what we found in our trial, this is another trial that's not published, uh, which was sort of packed together with this initial trial that we have published. We're just about to submit this other one. We looked at the short-term effects. So what that is those immediate effects that clinicians measure, because most clinicians will tell you shockwave does have a short-term effect. Patients feel better as soon as you do it. So we measured that with load test pre and post. And what we found is that in the first session out of three, the shockwave had an immediate effect. So it reduced pain by a small amount, but it did reduce pain. But that effect was no different to the placebo shockwave. Okay, so it's the same as so basically what it's telling us is that it's probably explained by just the expectation of the participants that we had. But the interesting thing was when we then looked at the second session and the third session of Shockwave, there wasn't that same magnitude of short-term effect. So they were sort of used to it by then, and some people must have thought, what, this maybe isn't all it's cracked up to be, and that expectation effect goes down. So it was really fascinating, that data. So we haven't quite published that, but that's going to come out soon,
Mm.
and that's going to be another talking point with Shockwave community, I think.
Oh, when so a lot of you said mostly what you do is lower limb tendinopathy. You've probably seen a lot of uh, cases of calcific patellar tendon, calcific quad Achilles, and if that's what they think is causing the long-term pain, what is the fix for that? Does that calcification need to go away for them to get better, or what's going on?
So that's a really good question. I use diagnostic ultrasound in clinic with all the patients that I see, and really when you look at the scans of people with, say, let's just take patella tendon as an example. If you look at the scans of people with patella tendon, they basically look all the same, but slight differences. So you've got a little bit of increased and irregular bone at the insertion. You've got a thick tendon. You've got a tendon that is darker in certain areas, and they'll often be referred to as a tear on ultrasound or MRI. It's increased signal, but it's still tissue that we think is just poorer quality tissue. So you've got those features. It's thick, it's a bit darker, and there's often irregular bone or a big bone. Sorry about that. Or a big bone spur growing into the tendon. And people look at it and they think that doesn't look good. You've got this big bone growing into the tendon. Sometimes it looks like a little finger projecting in to the tendons. People get quite worried about that. But I always reassure them that that is, that even if they go through treatments, the tendon gets stronger because it will, and their muscle gets stronger. They get more tolerant. that bone will still be there, and that's absolutely fine. And they won't have any pain at some point, but the bone will still be there. And we know that from, all the tendon sites around the body that, we don't necessarily need to cut that out. But it's an important thing to check with patients, particularly from a point of view of I always ask people, um, what have other people, what's in your mind? What's going through your mind? Obviously, you've seen lots of other people. What's going through your mind in terms of what could be causing this problem, or what could be contributing to this problem? What do you think's going on? And some people will say, I have got this bone in the tendon, and they think that's the cause, or at least part of the cause. And that's usually been told to them by someone else.
Mm.
So,
The
yeah.
yeah. I don't know who I was talking to recently. I was doing a show with someone. We were talking about like the kangaroo tendons, how they're really extendable, they strain a lot. And then you get
Mm,
to like the
mm,
turkey, they
mm,
do this research on bird tendons and they calcify, like their leg tendons calcify. And
mm,
I was kind of thinking, why is that the case? And I think I read it in a paper that they need a really stiff tendon. I guess those birds need a really stiff tendon, so that's why they
mm.
calcify. And the kangaroos need a really extendable tendon. Do you think that that bone, that calcification or that bone growing into tendon could actually be like the body trying to create a positive adaptation to make the tendon even stiffer? Or is it always like a bad pathological thing?
It's a really good question. Again, I think it's possible that it is adaptive because if you look at even some of the data that we have at the moment, um, I can't remember the authors, but recently I was reading some stuff around patella tendon, and they were showing that the patella tendon is really thick. It's really pathological when you got patella tendon problem, but it still works pretty well. They did a bunch of measures like stiffness and even the amount of energy storage, I can't remember if they did hysteresis or other things like that, but they just looked at all these biomechanical measures and they found that you had all these people with these really thick abnormal tendons, but they're actually still working well. So there's something adaptive going on. There's no doubt about that because these people go back to sport and they still have that same tendon when they go back to sport. Hardly ever does get better. It does get better, but it takes a long time to get better. I was actually reflecting on this the other day, um, why I'm not very good at predicting when a tendon's going to get better in terms of looking better with ultrasound. And that's because it just takes so long and you hardly ever see them back again. So you might be treating someone, they might get better at 6 months or at 12 months. You look at them at that time, the tendon might be marginally better, but it's still going to be really abnormal. But then now and then I've seen people back 3, 4, 5 years later, they might have another injury and they come back and see me. And I always scan the tendon, and then at that point, it looks much better. So I think the time frames for improvement in tissue are really, really long and much longer than what we're looking at. But there are a few studies now that are starting to look at those 3 to 5 year periods, and they're showing that yes, you can start to see a more normal tendon in that time frame, if you're looking at that time. So back to your question though, I think it possibly is adaptive in some way. It possibly is adaptive. And I think at some point the tissue is under so much stress, and it could be a mix of compressive and a mix of tensile stress that the tissue is just going to then, think, I need to be a bone. This is the only way that I can cope with all these stresses that are in this environment at this point. Um, so that, that's possible, especially as you start to get a thicker tendon, which maybe then you get more compression as you start to load it in certain areas. So yeah, no, it's an interesting question.
Hmm. Yeah, yeah. I mean, I'm still. So you're just done with Shockwave now.
Done, Done. Yeah, done. Which is it's a real U-turn and roundabout. But I thought I have to. I can't keep going.
Yeah.
I can't keep going if I've got a trial that, and it's not only my trial because obviously it's all the evidence that is mounting now, and I think I made this comments online to some of the because I've had all these people online, um, really coming out of the woodwork going, it does work. I know it works because I've, seen it in all my patients. They all get better. There's a lot of people very invested in Shockwave. So I think the thing with Shockwave is we're not going to resolve it until we have lots of high quality trials. We need more.
Mhm.
So we're probably about 10 years off not using it. But then having said that, we've got high quality trials in PRP and people are still using it.
Yeah.
So it's hard to change practice and also people's views if they're very invested in certain things.
Mhm. That was my next one, PRP, because a few in the States, the American football. I've consulted with a few guys, or even talked with medical staffs, and it's like guys will get a patellar tendon pain or Achilles pain, and they're so quick to get a PRP injection and then rest for 1 or 2 weeks. And most of them, I don't know, a lot of them are not better after that, and they're actually worse because they just deloaded for a while. So what's going on with PRP? Does it work?
So we do have lots of good studies now in PRP, and particularly in the Achilles. So in the Achilles, you can be very certain, given the current evidence, that PRP does not outperform a sham injection. So we know that for sure. There's no doubt about that. It's about as certain as you can be with anything that we have. And when I do talks and courses and lecture people, um, I sort of bring it up because it's quite a funny story that we, it is the thing that we are most certain about, but unfortunately, in the wrong direction, we're certain that it just doesn't work, and it's something that we shouldn't be doing. But even though that is the case, everyone still does it. Well, not everyone, but lots of doctors still do it. So I don't know. It's probably because there's no other options out there. So if you've got this NFL footballer and they're injured. They've got, they want to get back as quickly as possible. The medical staff's probably thinking, right, let's do as much as we can. It might just be a 5%er. It might give them something. Um, we don't want to be 3, 4, 5 weeks down the track or even 2 months down the track and they're still the same. And then we're thinking PRP. So I can understand what they're thinking, but I agree with you. It's very rare to get a positive effect when they're going down that path. So I think probably better off just not doing it at all and just sticking to other things that, even though they take time, we're more certain that they're going to get an effect.
Hmm. I've I've thought the mechanism, if we PRP and stem cells, I've thought the mechanism of stem cells sounds quite a more promising. But I don't know, is there research on stem cells and tendons like there is PRP? Where do you stand with that?
Yeah, so stem cells is also an interesting one. There's actually no as far as I'm aware, last time I checked, and it's probably been a good year since I've checked thoroughly, but there wasn't any trials. So nothing's gone to trial yet where they're saying, okay, this is going to be a placebo-controlled trial. Because the beauty of injections and shockwave and medicines is that you can really get good sham control. You can do a really good sham and you can really determine if something actually works or not. And that's really hard to do with exercise, but we can do it with all these things. So I don't think anyone's done that as yet, but people are using it, unfortunately. In Melbourne, very recently, it might be around across the whole of Australia, I'm not sure. There's a guy who's quite a well-known guy in the community here, sports medicine, who's set up a dedicated clinic uh, for stem cell injections. So that's his whole clinic now. So that's, I would say that's a bit of a, I'd say that's a bit premature when, to do that at this point, given that we haven't got that evidence yet. But as you say, it's a very compelling narrative, and, a story sells the injection. Because if you can tell people, look, these are stem cells, we know what these can do. These make any tissue that we want. Like, they use these to heal so many things. People are going to buy into that. So, and they'll pay a lot of money for it as well.
Hmm. Yeah, I just with the tendon, just a natural healing process is like it's supposed to get more cells in the tendon to help with healing. And I'm like, if
Mm,
you're maybe a very old elderly person, maybe you have a poor healing response. Maybe that like a stem cell thing would make more sense. But I'm thinking like a 20, 30-year-old, like I feel like you got plenty of stem cells for your own healing that I don't know if you
yeah.
need you. But is there not much research? There's not much research on stem cells compared to
No,
like
no,
PRP.
no. And I think, yeah, I would agree with your reasoning there. And I think the older people who have got, less of a good environment for healing, but it would probably be that sort of 10% benefit they're going to get. So you'd still need to do all the exercise, all the loading, all that stuff.
Hmm.
And ultimately, that's going to be the key. That's going to be the 90% for them.
Hmm.
So it might be a 10%er at some point.
Yeah, okay. So I guess I want to kind of stick on these adjuncts here before we get to the training because a lot of the yeah, t good tendon rehab is a lot about the loading, getting the loading right. What adjuncts are you kind of a fan of? Like one for me, I think of is like the heel wedges for insertional. That's
Mm,
has some pretty good evidence, or maybe I guess a bit for mid
mm,
portion. But what other ones are like just passive, more passive modalities that people can do? What things are
yeah.
you a fan of?
So look, I think anything that people can get their hands on that can have that is accessible, that it's fairly cheap and safe. Those three things. If you can tick those boxes, I don't think it matters too much what you're doing. Could be that you're doing some massage. Could be that you're doing some dry needling. Could be it could be the tape, or it could be something like the heel wedges. Um, that is absolutely fine. And I use all, so personally myself, heel wedges, yep, I use the heel wedges with, most insertional, most mid portion Achilles people, using things like tape, again, to try and reduce the amount of dorsiflexion people get actively when they're walking in the short term for just control of pain. What else? I don't really do dry needling these days or shockwave. Um, but yeah, they're probably the most. I mean, now and then I might do some hands-on work. Now and then I'll do some of that as well. So, it just depends on the individual, sometimes what they want and their expectations and all those things. But I'm pretty light on with the adjuncts. It probably stops there. So no machines, no nothing like that these days. But I can tell you give you a bit of an update on the heel wedges, because we recently did a trial on the heel wedges, which we're just about to submit to a journal. So it's all written up. So this is just a bit of a sneak preview of the findings that we got in that trial. It was run by a really, really good PhD student. His name is Jared Burke, and he did a really wonderful job. He recruited 100, I think it was 108 people, randomized them to two groups, and it was very simple, very, very simple. It was just a heel wedge versus a sham heel wedge. And we did it for mid portion Achilles. Uh, and basically, we didn't even do any exercise at all. So we didn't get them to exercise. It was just the heel wedge. So it was really, really easy to get people on board because they didn't have to do much at all. And what we found is that the heel wedge did have a significant effect uh, compared to the sham. Um, and it was small, but it was significant. But when you compared it when you controlled for, so we measured expectation, and that is, when you gave the person the heel wedge, or when you gave them the sham, which was just a very flat insole that they put into their shoe, just flat and across the whole shoe. When you gave it to them, when you gave them the intervention, when they found out what group they were having, and we didn't say anything about sham in the patient information for this trial. We said to them, we're comparing two different orthotics. That's all we said. So it was a bit of a limited disclosure. So when we gave them the flat one, and then we measured their expectations. So we asked them straight after, do you expect, how much do you expect to improve with the intervention you've got? The expectation of benefit was lower in the sham group. So when we controlled for that in our statistical analysis, the significance between the groups disappeared. So there's no effect if you cancel out the effect of expectation. So that was fascinating. That was really, really interesting to us. So again, it comes down to, is it accessible? Is it fairly cheap? And is it safe? And yes, it is. So we're still concluding that you can recommend them because they will have benefit. It's just what explains the benefit that's interesting.
Mm. And it's are you of the camp like it's probably going to be more useful in insertional than it is mid portion, or is it pretty equal?
I'd say I still use them for both, pretty much. But I think insertional, yes, it would be probably essential and more important. And there was that recent trial, well, it came out yesterday or the day before, I think, which I haven't read as yet. But the first author is Pringles.
Oh yeah,
It's
I just read that. Yeah.
Yeah. Tom Goom's been busy and got a slide about it online already. But basically, it seems like a really good trial. I wouldn't have a good read of it, but they've looked at doing something like a dorsiflexion restricted program versus a dorsiflexion program for insertional Achilles, and they found that the dorsiflexion restricted program is better. I've got to dive into sort of the specifics of that. So, so I think it does make sense to reduce compression for these people, particularly in the short term.
Hmm.
Um, my thing with compression is that in the longer term, you probably are going to need to provide that person with a tolerance to go into dorsiflexion at some point. At some point, they're going to have to go into dorsiflexion. Now, maybe you're not going to do that with heavy weight. Maybe you're not going to do that with, when they're very painful, but at some point they will need to go into dorsiflexion. So I think that's where, yeah, that's where I sort of stand with it. Dorsiflexion is not bad at the right time.
Hmm. With compression, so it's pretty, yeah, it's happening at the Achilles calcaneus. There was a paper where it was, I think it was, I don't know who it was, Joe Cook, someone else, many years ago. They were talking about the compressions of all the tendons across the body, and the patellar tendon, there was nothing with the patellar tendon. And I'm like, is it not getting compressed? But then there are papers on impingement and compression ideas around patellar tendon. Where do you stand with the knee? Is it like the quad
Mhm.
tendon has a noticeable compression on the condyles? And what about the patellar tendon? Is it like genetically, do some
Yeah.
people get more compression than others, or what?
Yeah, look, that's a really good question. I remember that paper. That was a really good sort of overview, and it was Jill Cook in 2012. I remember that paper because it's still one of the ones that I would sort of refer to for compression. Uh, and it was like outlining, here's all the different sites, and this is how they can be compressed. But it was a bit strange when you came to patella tendon that there wasn't, any talk of compression there. And that was based on some lab studies early on where they showed that, there maybe isn't any compression in patella tendon. But I think it was more limitation of the methods that they used in those studies. It just makes sense that there is compression. It's an insertional tendon problem. If you look at it with imaging, a lot of the time you got the patella and people think, and you got the tendon that inserts there, but the tendon goes over the top. So where you get compression is here. at the top of the tendon. And you often see a thickening of the tendon as it goes over the patella as well. So it's in my mind, it makes sense that there is compression at the patella, just like there is with all the other ones. It's just that it's one of those areas where the science has not caught up, or the science might have led us down another path that is not the right path because the methods aren't good enough. Um,
Mm.
so, it does make sense that there probably is some compression going on.
With the and with the quad tendon, it from stuff I've read, it seems like it's happening more in deeper deflection. With the patellar tendon, is it also more in deeper deflection, or where are you thinking the more compression is happening?
I think so. I think it would be the same because when you look at the pain that they get, often they get pain in those positions. They get pain when they go down to 60, 70, 80, similar to quads. Quads, maybe they get pain a little bit deeper, but they still get pain. So there's a linear relationship rather than a U-shaped relationship with pain and knee flexion angle
Hmm.
with a patella. I
Hmm.
think the more they bend, the more pain they'll get.
Um, okay, so let's get to training. I kind of had this list of things, and we've went off on Shockwave, which led us down a different path, but that's fine. The Where are you standing right now? There's so many studies on, or different opinions on the load used, and I maybe that started. Who was that? That systematic review on tendon stiffness. Is tendon stiffness is everyone something everyone's always after, and it was like the heavier the load, the more effect on
Mm.
tendon stiffness. But then you have
Yeah.
training programs where it's like high load works, medium load works, low load works,
Mm.
maybe
Mm.
BFR works.
Mm.
Where do you
Mm.
stand with load? What is the right load for tendinopathy?
Yeah. So it depends on the outcome that you're looking at. So if you're talking about tendinopathy as in treating pain and treating self-reported outcomes, then it probably doesn't matter what type of loading you do. So you could do something that is very, very light load. You could do something that is very heavy. It's going to target the tendon. You could even do stretching, and it probably is going to have some effect on the tissue, on well, at least on pain, self-reported pain. So I think when we're talking pain, self-reported outcomes, people getting better over time probably doesn't matter. But when we go to tendon properties and stiffness, then it does matter. It does matter. I think it matters a lot, the type of loading that you're doing. And that's where I think to try and stress the tissue enough to get some sort of adaptive response. And I think what's happened is we've forgotten about the tissue over the last decade, because everything is about biopsychosocial. It's about making sure that we're doing the right education, which I think is really, really important. But it's also at the expense, for some people, of the specificity of the loading that is required to get an adaptive response. So I think we need to be conscious that we're also treating a tissue as well as the person. So we need to look after the person, but also look after the tissue at the same time. So that's where the specificity of loading can be quite important when we're looking at uh, how can we get this tissue to be a better quality tissue.
Mm. Yeah, I talked to Jared Anflick. I think he's in London or somewhere, and
Mm.
I think
Mm.
I had brought up the biopsychosocial model, and he was like, if talking about the Achilles tendon and the loads the Achilles tendon experiences in an athlete, and it's like
Mm.
the bio piece, you can't psychosocial your way out of like a 80% tear of the Achilles tendon, like it's the
Yeah,
load bearing is so important, and
absolutely.
I did read that
Absolutely.
paper on the BPS for tendinopathy. But I feel like it's so much of the bio side, like the biomechanical side with tendons versus like
Mm.
low back pain. Low back pain,
Yeah.
you might not have
Yeah.
really a biomechanical thing. Um,
Mm.
yeah, so that's
Yeah.
interesting though that you're thinking that in the last 10 years people have kind of went away from that the
Mm.
tissue
Mm.
thing. Yeah.
Mm. Yeah, no, I think they have. I think they have. I think it's it is different to back pain. There is a tissue there. People also, I think that one of the main reasons, or one of the main ways that people that you deal with the psychological factors um, is by giving people confidence to load the tendon. And that comes from the progressions we do, from the heavy load progressions we do. So giving people the confidence to load the tendon is sort of how you deal with the bias, with the psychosocial part of it.
Mm,
So loading is really part of the whole strategy in biopsychosocial care.
mhm. Yeah. Um, so for loading, the frequency, there's so many. I mean, I'm thinking of Achilles now because it's like you have daily calf loading, then you have like every other day, or you have 3 times a week. Where do you stand? Is it really just like figure out what the person wants to do and what their goals are, and then that's the frequency they get? Or is there anything more like scientific that frequencies could matter?
It also then comes back to how what the outcomes are again. So you're going to be so if you want to do if you've got someone in front of you where you think, and this is where sort of individualized sort of care comes into it. But if you've got someone in front of you where you're thinking, this person just needs to get moving, to get a little bit more active, they need the confidence to be more active. It doesn't really matter what I prescribe for them. Then that is okay to just, they could do some light loading that they do every single day. They could do heavier loading a couple times a week, and it probably is going to come down to largely their preference and what they really want to do. Um, but if you want to target the tissue and get the tendon better, then that's where it has to be very, very specific in terms of how you're doing the progressions of loading and the type of loading you're doing. That's where it has to be very specific. So in I guess in my practice, I would try and do a combination of both. So loading for the sake of improving their confidence and pain, but also specific loading that is going to have a chance of improving and making the tendon better. So it's those two. So you're trying to hit both those targets.
Mhm. When it comes to um the I guess I said it earlier, the stiffness and that's one of the things for an athlete. Like you have to have a stiff tendon in the rehab process. That's one of the things you're probably trying to improve is how stiff that
Mm,
thing is, so it's going to be able to withstand high forces and not strain too much. Um, why do you think it is? It's been just repeated now for so many years that the high load training is what builds the tendon stiffness, and plyometrics are basically doing nothing to build tendon
mm,
stiffness. What do you think? I've asked so many people, like, why is this the case?
mm.
Yeah, why is it the case that stiffness is built from heavy, slow loads and stiffness is not changing from plyometrics?
Yeah. Yeah, no, it's a really good question. So that I think if you look at the mechanisms for how people improve their stiffness, that gives you some clues. So there's been lots of really good work over the last, and this is all sort of coming out of people like Keith Barr, people like Aaron Patsis, who's got a lab in Berlin, people like who else? People the Danish group do a lot of stiffness work. There's a couple of people in Ireland that do a bit of stiffness work, but there's now a sort of understanding that tendon is very responsive to loading, and we need to load at a certain intensity to get an adaptive response. So intensity is important. So MVC and the amount of load you're putting into the tendon and the muscle tendon unit is important. But what people are showing is that it's really about the strain in the tendon. So it pretty much comes down to strain. in the tendon. And when you're doing things like isometric loading or eccentric loading that is very slow, you're going to get more strain in the tendon, and that's going to lead to that adaptive response. So that's what leads to it. And even with isotonic loading, that could also lead to that adaptive response. It just depends how you do them. The current sort of thinking is that all these types of loads are sort of going to lead to adaptation and are pretty much the same. So there's not a huge difference, or there's not a, if you look at the evidence, there doesn't seem to be on a human level a big difference if you're going to do a heavy eccentric versus a heavy concentric versus a heavy isometric. But I think there might be a difference. And again, it might be a case of the science that we have at the moment hasn't quite caught up with what we're doing in clinical practice, or what what we know from a basic science level. So we know that if you strain a tendon isometrically, if you hold it at a certain point for a long enough time, you're also going to get an effect of fluid movement. So one of the things that happens, and it happens with all type of loading, but it particularly happens with isometric loading, is that the fluid starts to move out of the tendon. So tendon is a tissue that's basically made up of water and collagen. So you have the collagen, which acts like an elastic material, and you've got the water, which acts like a viscous material and resists compression. So when you load a tendon, there's interaction between those two types of materials, and you have water that is free in the tendon, all bound to proteoglycans that starts to move out of the tendon. So you have this huge amounts of fluid movement, and it happens particularly, we did a study that was published, I think, in 2022, and that was another PhD student whose surname is Mirza. So she showed that if you load the tendon heavier, and I think we did 75% of MVC, and we did it for 8 seconds. So 75% for 8 seconds, you get the best effect in terms of fluid movement. And we also saw that as well as fluid movement, the tendon becomes more compliant. So the tendon starts to strain more. So you get more fluid movement, more strain. So ultimately, what you're doing is you're starting to then get more strain into the tendon. And that's really important, because you're going to get more of an adaptive response. So that's a short-term mechanism for getting more tendon stiffness in the long term. So in the short term, you get more strain. In the long term, you get a stiffer tendon. So that's the fluid movement mechanism. The other mechanism is stress relaxation. So stress relaxation is the thing that Keith Barr talks about a lot, and he's got some really great insights in that area. So holding a tendon at a certain point starts to then stress the whole tendon rather than just certain parts of the tendon. And those mechanisms all interact. So as you start to get fluid movement will impact on stress relaxation. And so will sliding of fascicles and other mechanisms as well. So we know all this from basic science studies, and we've got little bits of evidence from animals and little bits of evidence, but we really haven't put it all together in human studies. So we still don't know things like, for example, how long, what's the best amount of time to hold the isometric contraction for? So should we be holding it for 5 seconds? We're going to get more intensity. It'll be more intense at 5 seconds, but not going to get as much stress relaxation or fluid movement. You will get fluid movement, because we've shown that even with 8-second contractions, if you repeat it enough times, you still will get the fluid movement. So presumably you do get some stress relaxation, but maybe not as much as when you're doing 30 or 40-second contractions. Okay, so there's a trade-off with some of these mechanisms. So we still don't know what is the best amount of time to hold a contraction. But I think isometrics early on are probably the best way to start to get an adaptive response. Um, as you go through the rehab cycle and they start to become more tolerant, probably the best way to get an adaptive response is with heavy maximal eccentrics. So that's later on down the track because people can then tolerate that type of loading a lot better down the track. So they're not going to be able to tolerate that initially. Yeah, isometrics followed by heavy maximal eccentrics is what I tend to do in the clinical context to try and get maximal adaptation. I don't really bother with isotonic for adaptation. Isotonic is good for muscle strength, but not so much for getting an adaptive response in tendon.
Mm. So like isotonic meaning like three down, three up, just normal lifting exercise, right?
Pretty much, yeah, yeah, yeah,
Yeah.
yeah. So I'll still do that. I'll still do that. So my sort of go-to is a bunch of isometrics, and they're doing that so they can adapt the tendon. And then they're building capacity in the muscle, but also control in muscle activation with isotonics. And then they start to do the isotonics faster to build power. And at that point, I also then would put in some maximal eccentric at some point as well. So that's sort of how I think about it. Not so much. Yeah, isotonics is probably the worst way to get, or if you're really focused on tendon adaptation, it's probably the least best. Still going to work, but not as well as the other
Yeah.
ones.
Yeah, because is it because the load you just can't lift that heavy of a load doing that slow tempo.
Can't lift the heavy load. Also, you have to do it very slow so they get some of that stress relaxation and those things. So it has to be super slow. The load isn't as much. People tend to rush it. Their technique is not as good. It's limited by the weakest points in the length tension curve. So say you're doing a hamstring and you're doing it on a leg curl machine. The weakest points in the length tension curve will be in a shortened position, so in a range position, and that's gonna dictate how much load that person pushes. So that means and that's pretty much why it's weaker than the isometric option. So isometric's always going to be better, but I think the king of all adaptive stimuli is probably heavy maximal eccentric. But there's limitations with that because it's hard to put in, it's hard to do well slowly until later on down the track.
Yeah. Give me what's an example? What are you using for Achilles for patellar with these maximal eccentrics?
So with the maximal eccentrics, it's good to do it in a machine. So machine based. So I would use either a Smith machine, and they'd be doing the standing in the Smith machine. They'd be going over a step because you need to go into maximal dorsiflexion to harness that stretch of the tendon. So they would just be doing, so they'd go up with two legs. They'd go up with two legs with really heavy weights. So the weight would be so heavy they can't go up with one. So it's maximal, and then that hold at the top and slowly go down for about 5 to 6 seconds. So I generally would do 4 sets of about 5 to 6, so quite low, and maximize the amount of load. So one of the things that we're really interested in doing at the moment, and I've got a PhD student who's going to be working on this, is looking at how much strain happens in the tendon when we do that. So that would be really cool to do. I've got a PhD student who just started, and we're trying to work out the best way of doing it. And the challenge is, attaching the probe in the calf muscle to monitor the muscle tendon units, and making sure it's stable and in the same spot. So we really want to look at how much strain happens, say, with something like that. So if you max someone out completely and you say they can do a single leg calf raise isotonically with say 40 kilos, and then you max them out with eccentric because they go up to 60 kilos or 65 kilos, then how much more strain do they get in their tendon when they do that? So that's what we're looking at trying to do. And the same with isometric. So the isometric would be in a Smith machine. You can do it in standing, do it in seated. And they can do either a holding isometric or a pushing isometric. So pushing is where they're pushing against something immovable. Some people call it, I think the other terminology is yielding and
Overcoming.
overcoming.
Yeah.
Yeah, yeah. So yielding and overcoming. So either pushing against a really high stack, so they can't move the bar, or the bar is fixed, so they can't move it, or they're holding a certain weights. So again, we don't really understand, and something we're really interested in is what are the differences in humans when they do that. So what are the differences with strain? What's the differences with with some of these other mechanisms like fluid moving out of the tendon? So that's what we're starting to look at now, and that will guide what we do in terms of how can we actually put in a load that's going to adapt these people. The other thing that's really important with isometric is the position of dorsiflexion. So the more dorsiflexion they have, generally, the more pre-stretch they have on the muscle tendon unit, the more likely they are again to get an adaptive response from that. But we just don't know. I mean, a lot of people do their isometrics up in plantar flexion, which I think is good in the short term because it's going to be less painful. But in the long term, you don't want that. You want to do it in dorsiflexion, at least some amount of dorsiflexion. So, so that's a real opportunity to get a little bit more load into the tendon.
Mm. So this this whole thing about the stiffness is seeing this increase in stiffness is probably coming from straining the cells, the whole tendon, and then getting down to the cells so they can whatever make the tendon stiffer. You're thinking that this reason why the tendon gets stiffer from the heavy loads, it's all about strain to you. That's it. It's all about the
No,
level of strain on the tendon.
no. I think it's more complex than that. It's more about you've got to try and think about all the mechanisms. So it's about you've got the three key mechanisms are going to be fluid movement, because it is about mechanotransduction and stress on the tendon cells. But there's different types of stress. There's shear stress from fluid moving past the cells. There is compressive stress. There's tensile stress. So we need to think about trying to put a stress into the tendon that's going to optimize adaptation. And it could be individual as well. So think about the Keith Barr stuff. If you've got someone with a patella tendon, it makes perfect sense because they've often got a big hole in their tendon, a big dark hole in their tendon. So you want to stress shield, you want to relax that stress shielded area and load it. That's what you want to do. But if you've got someone with an Achilles that's just thick and pretty homogeneous, the whole thing looks the same. It doesn't work that way. It's a different type of mechanism. So I think it also depends on how the person is presenting. And that's where imaging can be useful, because you can then start to think, okay, do I want to do a longer isometric and really target that black hole or that area in the tendon? Or is it okay for this person to do something higher strain and just focus on strain? Because we know from the work of Aaron Patzis that You can just strain a tendon really heavy. He does 3-second contractions,
Hmm.
which are really hard to do clinically because it's such high load. So he does these 3-second contractions and he does loads of them. Well, he doesn't do that many. I think the total time of attention is like 60 seconds, so it's not long. But he does these 3-second contractions and he gets really good adaptation of the tendon stiffening. So, and Keith Barr's work is different. That's a higher duration, lower intensity, and that gets good adaptation too. But it might depend on the person that you've got and the lesion there that you've got as well. The other thing that's really interesting is the fluid flow, because we know that within the tendon, and especially pathological, there's going to be stacks of fluid in there, stacks of that increased water. So I think there's also a need for some people to try and just basically try and remove as much of that excess water as possible. And then it's going to behave more like a normal tendon. And that excess water and compression might have some impact on pain as well. There was a really good narrative in BJSM. You might have seen it about sort of compression and thickness, not the one that we're talking about with Jill Cook, but a newer one. I think it was Pringles
Yeah, there was
again.
the
Yeah,
intertendinous pressure one.
yeah,
Yeah,
that's the one. That's
yeah.
the one. Yeah, yeah. So that was really interesting because I think there's something in that. There's a lot of pressure. If we can get rid of some of that fluid with fluid flow, it will start to signal better, and it will probably start to then adapt better as in terms of stiffness and act like a normal tendon again. So I think they're the sort of three mechanisms that I think about.
Yeah. The that paper was it started with an M with the isometric and getting the fluid out. You said it, Mirza or something. Yeah, yeah,
Yeah.
yeah. I remember.
Iman Mirza, who was a PhD student who finished a couple of years ago. Yeah.
Okay,
Yeah.
so yeah, I remember reading that, and it was that fluid was coming out with that higher intensity isometric, and then in that intertendinous pressure paper, he was speculating that heavy slow resistance, I guess isometrics fall into that, could be a method to kind of squeeze out this fluid and get things
Mm,
normalized. Do you think, I've just kind of thought like when someone does have a tendon like that, obviously pain is so complex, but if we
mm,
think the fluid, the intertendinous pressure is causing this discomfort and whatever, when you just
mm,
warm up the tendon, it always feels so much better. So I'm like, does does a regular warm up, does that still get the fluid to kick out, or do you need to do some type of like heavy isometric hold? Is there
mm.
any research on this or not?
That look, it's a really good question, and this is the sort of stuff that we're going down the path of now. So we've done one study. The lead author was Pearson. It was published in 2018, and it was in the patella tendon. And we looked at the thickness when they're doing different types of isometrics. We looked at 10 seconds versus 40 seconds, and we found that there was a wringing out of fluid. The thickness reduced with both 10 seconds and 40 seconds contractions. So that's telling us at least that we can do short contractions and it will still get that fluid movement effect. But we don't really have much data in humans. A lot of the data is in animals, and it's hard to sort of say how that's going to relate to humans. Um, but I think that if you do a warm up, say you wake up in the morning and you put your foot down and your Achilles is really stiff and you feel really painful, that's more of a neural I want to say uh, sort of pain neuromodulation type effect that we're probably getting there when that starts to warm up and people start to feel better. I don't think, because obviously most people will put their foot down, they'll be really painful, they'll take 10 steps, or they'll go and have a bit of a walk and they'll feel better. I don't think that is enough to get fluid movement. But it hasn't been tested.
Mm,
Hasn't
yeah.
been tested. So no one's tested that. We once considered a study where you get people to sleep over and then you measure them first thing in the morning. But it's a hard study to do because you got to get people first thing in the morning and measure biomechanical properties of the tendon, which is tough. Um, so no one really knows.
Mm.
why the pain gets better. It could be fluid movement. It could be that the pain system is changing and they're tolerating those loads a bit better. They're starting to ignore whatever signals are going to their brain a bit better as they start to move around a bit. So yeah, so no one really knows what the optimal way. But I think going back to that paper in BJSM, I think what might work a bit better is if we do heavy isometrics rather than the heavy slow resistance to try and wring the water out. Because those mechanisms of the mechanisms of stress relaxation that Keith Barr talks about and the mechanisms of fluid movement are overlapping. So partly once you start to move the water out, you will get stress relaxation. That's part of it. But it's also sliding of fascicles as well. So it's not just related to the fluid movement. So what we need to untangle is the best way of maximizing those mechanisms in a pathological tendon.
Mm.
And that's what that narrative was talking about, which I think was a really good direction to go into.
When when it the tendon does get pathological and it's I guess you can see it thicker, whether that's fluid, blood flow, whatever it is, and we want to kind of get it out to normalize things. Have you? I mean, I'm of that point too, because I'm like the tendon hurts. It's kind of like bogged down with fluid. Let's try to kick everything out. But I'm
Mm,
like, it's got to be
mm,
there for a reason. All that fluid
mm,
and all whatever.
mm,
You're like, why did the body put all this stuff in here just to like gunk up the tendon? And is
mm,
it something that might naturally go away over time? Or is the tendon like such a sensitive tissue where it's like it
mm.
needs good loading every day and we need to really, I don't know if you have any thoughts on that.
Yeah, look, they're really good thoughts, and they are questions that we need to tackle and get a bit of certainty too. My sort of thinking around that is that the body did put it there for a reason. I mean, because we think about a tendon problem as an overload, overuse problem. That fundamentally that's what it is. So it's a tissue that is surpassed the ability to take we're putting more load into it than what it can handle at some point, and it's responding, and the cells are responding, and they're putting down all this material, this new material, and we know that pathological tendons have a real high metabolism. They've got a real high metabolic rate compared to healthy ones. So something is happening in these tendons, but obviously it doesn't go in the right direction. So I think we can understand more about how we can push it into the right direction slowly. That's my thinking. But I think we also need to think that in the short term, it's probably there's collagen there that's not very good or not as good quality. So maybe the thickening is a positive thing because it's allowing it to be a bit stronger in the short term. So I think it takes a long time to adapt and slowly with the right loading, it does get there. But it's hard in humans because it's not like some of the animal work where you can just control everything else and all the loading they do. These humans are walking around doing things, running, playing sport, and then you're doing your loading on top of that. So to work out how to optimize loading to bring about response that is positive over time is difficult. But I think one of the things we haven't got right is the time frame. So the time frame for tendon adaptation. So when I'm looking with ultrasound, I always just follow them up because it's of interest, and I just like to see how they go. So if I'm seeing someone, I'll just pop them onto the table for 5 minutes as part of the consult and just see how their tendons are progressing. And that what I've learned from that is that they don't really, and we know this from a lot of the studies that are out there, they don't really change in the short term. You might get a little bit of increased thickening, and someone's in there in the room with me and they're like, how does it look? Does it look better? I don't know how to answer that question because it's a bit thicker than what it was like, a month ago. And I always say to them, this is not judging if you're better or worse at this point. This is just for me to look at the tissue. We're focused on how you feel, how you can jump, how your strength is, etc. We're not focused on this. This is not how we're judging it. But of course, they want to know if it's looking better or if it's if it's changed. So, but yeah, over a year, it will change. It will improve over a year. So I think the time frame that we have looked over in most studies, 3 months, is not long enough to understand how we can optimize. And also the time frame that we tend to load people for is probably not long enough as well.
Mm. Yeah, the yeah, that's not something anyone want to hear, huh? It takes years, not months. The yeah, the changes in a tendon, I'm like, even like th thickness changes, if you're going to see a positive thickness change, like that's going to take many years of you loading in a specific manner, loading that tissue. You can probably see a thickness change in the short term that's negative. If you overload the tendon,
Mm,
it just gets bigger. This whole thing on the water, that water movement squeezing out because like the tendon feels better. You can maybe you could even see it be a little smaller after some of these things.
mm,
Where's the water going? Like if that water is bound to the
mm,
proteoglycans and the GAGs, I don't even know how to say it,
mm,
glycosaminoglycans
mm,
those things want the water next to it. So like if you're
mm.
kicking out the water, are you kicking out other things too? Yeah, like where is it going in the bloodstream? And then when is that water going to come back and swell again?
It's a good question. So it's it's a real it's because it's such a viscoelastic tissue. So you've got, I mean, the water in the tendon is serving a purpose. It's really important. It allows it to be more elastic. And we know that there's a stack of water in the interfascicular matrix, which is part of that sort of elasticity of the tendon, especially the Achilles tendon. So this water is actually helping that tendon to be more elastic as well. But that's really useful for when you're doing sort of ballistic movements, hopping, plyometrics. When you want to load a tendon slow, get an adaptive stimulus to those cells, you want to strain the cells, and the water going out of the cell is helpful then because it will allow the tendon cells to have more strain stimulus ultimately. And also you get the shear forces from movement of the actual water itself. So, so it basically just goes out for a short amount of time and then it's recovered again. So in a normal tendon, you'll have a movement of fluid out of the tendon, and we showed this with Iman's work that basically just goes out of the tendon, and you get a change in volume, and then the tendon is a lot more compliant. It is able to strain more in that short term, which is an interesting concept in itself because then in the long term it becomes stiffer if you do that a lot. So it's this short term response of the tendon to get a bit more efficient at straining if you do the things slowly, like isometrically. That really has a good effect on that. So it's part of that adaptive process in some way. Um, and it's something that we do need to consider when we're thinking about, trying to adapt a tendon.
Hmm. So when you do something fast, like a vertical jump or something, this is it just like not enough time to allow for this fluid movement? That fluid just stays in.
Exactly, exactly right. Yeah. So there's bonds between. So you got the glycosaminoglycans, you got the proteoglycans like decorin. So this decorin molecule is bound to collagen, and it's bound to some of the collagen fibers. And when you slowly load a tendon, some of those bonds break. But when you do it quickly, they don't. They don't have time to change biochemically. So they will stay there, and the tendon will just have this stiff response to that ballistic loading. And part of that stiffness response is related to the viscous material that's in the tendon as well. So that will contribute to that stiffness response, and that's a good thing because you want the tendon to be stiff when you're doing ballistic movements because it helps to protect the tendon against injury. It's also helps it to store energy, so you get some of the storage of energy within those viscous parts. So it's a really important part of it. But yeah, when you're doing it quick, you just don't get time for that fluid to disperse as you
Mm.
do when you do it slow.
Yeah,
Yeah.
okay. That answers some questions. I had a podcast with Hazel Screen. She does all this, the intervascular matrix stuff, and um fascinating,
Yeah.
but still really confusing for me of the dynamics of like what's going on in tendons. But that does help the fluid movement and like how that could potentially be adding more stress to, or more strain to the tendon cells, getting more adaptation.
Mm.
And that does that kind of line up with like why are you not seeing this adaptation from plyometric studies? You know, if it's like
Mm.
because maybe those
Mm.
cells are you're not getting all those things you talked about, you're not getting these stimuli on the tendon cells, so what are they going to adapt to?
Yeah, exactly. The thing with plyometrics is you don't get as much of those mechanisms we talked about, like the stress relaxation and the fluid movement. You don't get as much of that. You will get it, and I'm sure there are studies out there showing that you do get it, but probably not as much. You do get a lot of strain though, which is interesting.
Hmm.
So with if you're doing hopping in the Achilles, you're going to get about 8% strain. If you're doing a maximal isometric, you're going to get about 5 to 8% strain as well. So it's quite similar, if not higher. The other difference is the time, the amount of um, time the contraction's held for. So with ballistic movements, obviously it's like zero point 0.4 of a second when you're doing hopping, whereas with your, or even lower, zero point 0.2 of a second, zero point 0.3 of a second. But when you're doing the isometrics, you can actually hold it for as long as you want and get that input. The other difference is that a lot of the stress. Now, I'm not sure about a lot. This is where you need to go back to Hazel Screen because she I've heard her talk about this, and she's talking about how the actual intervascular matrix and all the fluid in it actually takes a lot of the stress of that sort of sliding and that sort of ballistic strain of a tendon, which is really fascinating. So you're not actually loading the fascicles or the tendon cells as much, is my understanding
Yeah.
from what Hazel's been talking about. So when you do a hop, when you're doing a hop or you're running along, you're still getting stretch, shorten cycle, lots of strain, but that strain might be taken up by a different part of the tendon to when you're doing these sort of slow isometric holds for a long time.
Mm. Yeah, so yeah, okay. Maybe those fast ones is like shielding the tendon cells from that strain, or maybe the
Mm.
fascicular tendon cells from the strain, whereas maybe you could actually start to strain them if you hold something heavy. Yeah. Uh yeah, definitely. It's hard. I think yeah, she's had some a good paper too with Jill Cook kind of laying out the how the initial damage is in the intervascular matrix, and then you can start to
Yeah.
tap into the fascicular collagen. But I one more question I got for you. We're kind of over time. I said an hour. We're kind of past that, but
No, no,
all
all
this
good.
talk, all this talk on getting this. So it's going back to like you're talking about the isotonics are kind of not enough to get this boost stiffness gain. You're more a fan of the heavier isometrics, the heavy eccentrics. Um, where do you stand with BFR for tendon adaptation, or is it not adapting tendons?
Yeah, really good question. Really good question. So BFR is an interesting one, because when you go back, say you go back 10 years ago, and we had the Bohm systematic review, which was the sort of one that we all went to at that time, and it was reviewing all the papers talking about 70% MVC is the cutoff point. We need to load about 70% MVC or 70% of 1 RM. What we now know, and this has come out of the last probably 10 years since that review, is that there's not a very good relationship between MVC and tendon strain. So you could do an MVC for someone who's got a very weak muscle, but a stiff tendon, and you could do it to 80% and still not achieve a lot of strain because the muscle's quite weak in comparison to the tendon. And the same, it goes the other way as well. You could have someone with a very strong muscle and a very compliant tendon. Now, generally, things should be in tune. So most people will have a muscle that's in tune with the tendon. So you don't get that a lot, but it is possible. And you see that with some of the data that's been shown where some people get enough tendon strain to lead to an adaptive response, even with 30% of MVC or 35%, 40%. And that's where I think the BFR evidence is coming in. So some people are just able to strain enough at that low level. And a lot of these BFR studies, they're using people who have got issues like post-surgery, or they're using people who are very untrained. So these untrained people, they're gonna strain their tendons much more easily. So you put them in a
Mm.
BFR training at 30, 40% MVC, they're probably going to get enough strain for an adaptive response. Okay. So I think it does come back to how much they are actually straining. And that could be a really nice study to look at that. So how much strain are they getting with that 30 to 40% contraction? Because that's the tricky thing in clinical practice, knowing are we straining enough? Um, I don't think there's such a thing as straining too much. Say when you're doing an isometric, you're probably not going to get a negative effect from that, but there is such a thing as not straining enough if they've got a stiff tendon already. But then
Mhm.
again, if they've got a really stiff tendon, maybe you don't need to strain too much and you
Yeah.
focus on the muscle,
Yeah,
you
yeah.
know.
Yep. Um, I get a little bit more on that. I I just talked to Gerard McMahon yesterday, and he wrote that paper, No Strain, No Gain. So like when you're talking about
Yes.
the strong
Yeah, yeah,
muscle,
yeah.
compliant tendon, like that's kind of really
Mm,
paints that picture really clear, and um,
mm.
how BFR could be useful for someone with a very compliant tendon.
Yes. Yeah,
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 that
absolutely.
just easy to strain. But I was
Yeah.
asking him, I'm curious on you, is he thinks of tendon adaptation as this strain thing, kind of things you're talking about, the slower heavy loads getting high strain on the tendons, and that's going to lead to adaptation to get the tendon stiffer. Um,
Mm,
but
mm.
I might have been reading recently, and I've just seen it, I guess other places too, is what
Yeah.
about like IGF-1 or growth hormone or these things where like lactate floating around? Can these things
Yeah.
get on the tendon or
Mm,
have some interaction with the tendon cells to lead to tendon adaptation? So there is like the loading aspect, and they're probably both have components going on at the same time, but that strain aspect, that loading aspect, is there also a metabolite aspect or like a hormone aspect to tendon adaptation?
mm. Yeah, look, I think the way that I sort of think about that is you need to have the right environment to actually adapt in the first place. So metabolism of the tendon, and this is where I'm, completely not an expert, and I really admire listening and love listening to people like, Michael Kerr and even Keith Barr, because they've got that sort of foot in that metabolic camp. But yeah, it's so complex. And I think there are so many things, metabolic factors that can influence metabolism. And then you've got diet on top of that as well. So the way that I think about it is you've got to be healthy, first of all. You've got to be healthy. You've got to have the right environment to have that adaptation. And then diet is probably a part of it as well. So I'm sure there is lots of factors metabolically, and it might be that there are genetic variations in people as well in terms of how they signal and how they metabolically adapt. So I think there are. I think I have heard Keith Barr talking about, metabolic differences as well. So it's complex. It's complex, and we're looking at it from one end. We're sort of talking about loading and all the stuff we do here. But then there's also, is that person ready to do all that stuff from a metabolic point of view within the tendon? I had, some patients you just think, how am I ever going to get this tendon to start to heal again? I had a guy the other day he's in his late 60s. He's lovely guy. He was a Vietnam veteran, and he's got some health issues now. So he's got diabetes. He's overweight. He's recently had a amputation of a couple of his toes on one of his feet. And on top of that, about 2 weeks after the amputation, when he was immobilized and then started walking again, he ruptured his Achilles
Mm.
on that side. So now he's seeing me for this Achilles repair, not repair, non-surgical care, because no surgeon would go anywhere near him
Mm.
because he was had all these issues. He's also a smoker as well, so he's a real challenge. You think to yourself, is this tendon going to heal, over 12 weeks at all in someone like that? So I think the environment is a really important part of it as well.
Mm. Wow. Yeah. Okay. A lot to think about after this one, but why don't you tell everyone you got quite a few things online. You have your own podcast too, so tell everyone where to find you.
Fantastic. Thanks, Jake. So the main thing is there's a website which is tendinopathy and I do training courses for people by request. So people would, often most of the courses I do these days, because I'm full time at Monash, are like someone will email me, say, can you do a course? So I do training courses, but I also do some in Melbourne, like a couple of times a year. But there's also an online tendon course. But I would say to people, don't buy the online tendon course because it's just about to be updated, and we'll be doing the update in the next month or so.
Mm.
So if this is going to come out soon, it's going to be probably end of March, early April will be the new course. So yeah, so that's basically the website's probably, but I'm on Twitter, X, and also on Facebook, and I do probably most posting these days on LinkedIn. Instagram, I've never really got onto. I don't know why. I do post there, but I never have done a lot on there or have really understood how it works.
Mm.
But LinkedIn seems to be the main one for me at the moment.
Okay, yeah. Yeah, I did your course when I first got into tendons, and that gave me like such a good foundation of understanding of what's going on. I'm reflecting too on our first show because you were talking, I think it came up with the heavy slow resistance versus plyometrics, and you had said the heavy slow gives you the time under tension and the
Yeah.
plyometrics don't. And it's been in the back of my
Mm.
head for 4 years where I'm like, I remember you said that, and it's like I've talked to all these experts, and it's like they're just
Yeah.
confirming like this is giving
Mm.
the tendon some time under tension, and then the cells can feel it. And
Yeah.
yeah, it's just crazy you said it
Yeah.
so long ago, and
Yeah.
I
Yeah.
was just like,
That,
I, it wasn't enough for me, but now I've been like piecing it all together. Yeah,
yeah. Yeah. It's good to see that some things haven't changed then, at least.
yeah,
But the
yeah,
understanding has become a bit deeper, which is good.
yeah. Well,
There's a
all right,
bit more
Peter.
there.
Thank you for coming on. This has been great.
Fantastic. Thanks a lot, Jake. Thanks for having me.
Yeah.